Hello everyone, we are starting lesson 28 in our Saxon course 3 and we're talking about scientific notation. So the first thing we're going to do is our power up, and our problem for power up number 1 is... Okay, everybody look at the problem and give me the answer. The odometer read 235 miles. Seth drove north until the odometer read 245 miles. Then Seth drove south until the odometer read 254 miles. How far is Seth from where he started?
24.
Okay, now let's draw a picture. Okay, we got to draw a picture. He was going, yeah. So we're going to draw a picture, and he was. He started with 235 miles.
It's like 500.
Okay, that's where he started. He drove north, so let's just go north.
1 mile.
And then he said 245 miles. So how far did he drive north?
10 miles.
10. Okay, and then he drove south. He drove south until, so he went north and then south until the odometer read 254. Okay, so he went down 9. Okay, and then how far was he from where he started?
1 mile.
1 mile. Very good. Okay, so he went due north and due south, didn't he? Okay, B. If a spoke is 12 inches long, then the circumference of the wheel is a little more than how many feet? Circumference equals what?
Half pi something.
2 pi r. Circumference equals 2 pi r. So what is the r? 12 inches. The radius is 12 inches. So we have 2 pi 12. So if we were going to leave it with pi, it would be what?
3.5.
Okay, so 24 pi, right? That's what I'm trying to get you to say. 24 pi. If you left it in pi, but we're not going to leave it in pi. We're going to say pi is 3.14. Okay, so who can give me what 3.14 times 24 is?
Give me a sec.
Who can do that one very quickly? 3 point, or go do it on the board if you want to. Yes, go quick. 3.14. I can have 2 people up on the board and see who gets it first. 3.14 times 24. Nobody wants to try? Do it on your paper? Rodney, you're not doing anything. I need somebody to let me know when the recording stops. Okay.
75.36.
75.36 is correct. 75.36 is how many feet he went. Well, we're not done. That was how many feet. That was how many feet.
How many inches?
So we did a lot harder problem than we had to do. You guys, how far is 12 inches?
75.
No, you didn't miss out. Just look at the 6.
That's 74. What's wrong with that?
Okay.
Raise it up.
Shh, everybody, it's pointless. Kira,
Oh, it's 75.
we did the wrong problem. Listen.
Inches.
Shh, it's in inches, and then it goes to feet. So what should we have done right back here? We should have said that 12 inches was 1 foot. Then we would have had 2 pi, and it would have been a much easier problem. So we're going to have to erase the 24 pi.
Am I done?
You're done. And we're going to make this. Now, this is 1. We're going to make that 2 pi feet. Does everybody understand why we changed from inches to feet?
Yes.
And so, guess what? All of that work that we just did,
is now gone. Oh, how sad. And we're going to say 2 times 3.14, which is much easier. 3.14 times 2
Is
6.38
28.
times 2 is 6.28. And that is how many feet. That was a lot of work. But it was such an easy problem, we did it wrong. Okay, so everybody go to this one. Give me the answer. Who can do it in their head?
48.5.
No. You can do this one with distribution very easily.
Oh, I know this one. Can I do them both?
Okay, first give me the answer so I know you've got it.
Oh, well, I know the answer. I know how to do it.
If you know how to do it, the answer should be right there.
Oh!
It's 40.5.
Nope.
No,
I literally just said that.
All right. Okay, everybody, let's turn it around. 4 times 10 plus 1/2. You can take a mixed number and split it up. Now you can distribute, and what do you get?
42.
No. So 10, yeah, you're right, 42. Okay, so 40 plus 2 is 42. Okay, does that make sense? So basically you're taking 10 times 4, and then you're taking 1/2 times 4, and you're adding them together. All right, does everybody understand that?
All I did was just turn it into.
Okay, next one. Let's go. If 3 gallons cost $7.50, how much would 4 gallons cost? $10. And he is correct. Now, you want to explain to us how you did that?
Well, 75, 7.5. It's basically 25 times 3 is 7.5.
Okay. So a third of this. So we're basically dividing both by 3 to see cost per gallon, right? So you're saying there's 2.5 per gallon, which is correct. And since it's 2.5 per gallon, then 4 of them would be another 2.5 added, or 4 times. Very good. Very good. All right. Power and root divide. Okay, power roots. They're just saying that's the. Very good. 30 is the answer.
Oh, actually, it?
Yeah, that's right.
Okay. Very good.
30 times 3 is 900. Oh, I know this one.
Give it.
It's like, well, I know how to do it, you know? So,
Do it in your head.
I don't know how to do this in my head.
Come on.
I can do it on paper.
You can do it in pieces. 48 divided by 6 gets rid of the fraction on the
Oh,
bottom.
that's 8.
Uh-huh.
And then 48 divided by 5 is...
No, you don't divide. 5's on the numerator. 5's on the top.
Oh, so it's, so then why did you divide
40.
40. Very good. Okay, now watch this. We're going to go slow-mo here. 5, 6
Oh, I get it. He multiplied.
times
He multiplied the 5.
48.
By how much you had to multiply the 6 to get 48.
over 1. So basically, guys,
What you do is...
isn't this simple canceling?
Cross cancel.
8. Okay, so this
You
is
do that on paper or in your head?
On paper.
5 times 8 is 40.
She was telling me to do it in my
Oh,
head.
but you can do it either way. I can do it in my head. You guys are learning to do it in your head. So, okay, so now look at this one. What do we do when we have 2? We have a proportion.
X is 21.
Yeah.
Okay, x is 21. Now remember the pattern. You multiply this way, only over an equal sign. I see some of you doing this on normal math problems, only over an equal sign. You get x equals, yes, here,
What you can do is multiply that here. You can
21.
multiply and do 7 times 3 is 21. And then
Right.
divide by 1. You can't divide by 1.
All right, here's the big one. Everybody go.
Excuse me, what?
Oh, wait, no, I need a pencil. Where's my pencil?
Well, where's my pencil?
No, Brandon's going to get it. Okay.
Now this one is a piece of candy.
Oh, yeah. 49, 7,
You're supposed to have one in here. 60. No.
It's 16.
No.
What?
You see these down here?
No, okay.
It's 2. It's 2. Very good.
I'm not stuck up on the first square.
Okay, you didn't see the bottom two, did you?
I accidentally grabbed 2.
All right. Okay, now, so basically that was. All right, so we're gonna, let's do it together, everybody. I want you to see how we're getting there. Okay, we're doing 180 minus 80 is 100. I want everybody to watch because I want your brain to start working this way. 100 divided by 2 is 50. 50 divided by 2 is 25. Square root that. 5 times 9. 45 plus 4. 49. Square root. 7 minus 6. 1 times 17. 17 minus 1. 16. Square root. 4. Square root. 2. Very good.
Multiplied 45 times.
Okay, so let's put the answer here is 2. Okay, very good. And now we're starting scientific notation, everybody. And we are talking about scientific notation is a method of writing a number as a decimal number times a power of 10. That scientific notation is a useful way to express and manipulate very large or very small numbers that take many places to express in standard form. For example, the speed of light is about 300 million meters per second. In scientific notation, we write this number as 3 times 10 to the 8th power. 3.0 times 10 to the 8th. Now, this is what we're doing. Watch carefully. 300. I'm going to do this one for you.
I just did it.
0, 0, 0, 0. How many zeros? 1, 2, 3, 4, 5, 8. 1, 2, 3, 4, 5, 6, 7, 8. One more. I got it? Okay. Now, look. When we're doing scientific notation, we're always going to have a number times 10 to the something. Okay? Now, the something up here, this exponent, will always be the number of places that we have to move the decimal. And what we're going to do is, so here's the decimal. Always at the end of a number, right? So let's see how many places we have to move it to get it right after this first non-zero number. All right, ready? Count with me. 1, 2, 3, 4, 5, 6, 7, 8. Now, we had to move it to the left, okay, to get 3. We moved it left 8. To compensate for that, we're going to put positive 8. It's always going to be the opposite of which direction we had to go. Now, 3 times 10 to the 8th is a very, very, very big number, isn't it? So isn't this number the same thing? So we're never trying to change the number. We're just trying to write it in a different form. Okay, so let's look at this one. And it says, this is what we're going to have, 3.0. The first 3 is the coefficient. The coefficient is written with 1 non-zero digit to the left of the decimal point. So 3.0. The power of 10 is the multiplier that turns 3 into 300 million. Notice that the exponent 8 corresponds to the number of places the decimal point shifts. Okay, so we are going to be using this. In other words, if we're talking about something that's in, this one was in the 100 millions, and it was 10 to the 8th. Okay, so this is just kind of a little cheat chart, but what I always do is just count decimals. Okay, so Earth, example 1. Earth's average distance from the sun is 93 million miles. Write 93 million in scientific notation.
Can we put it on the board?
Yes, go ahead.
All right.
So basically, I'm going to do it here, and you go ahead, and I'm not going to say anything. Okay. So I have to go right behind the 9. Because this digit here must be between 1 and 10. So I have to go back there. So 9.3, okay, 9.3 times 10 to the what? Okay, look. 1, 2, 3, 4, 5, 6, 7 to get the decimal right there. So change it to 9.3 times 10 to the 7. 9.3 times 10 to the 7.
Here we are with example number 2. When Brigitte finished the 1,500 meter run, she announced that she had run 1.5 times 10 to the 6 millimeters. Write that number in scientific notation and in standard form. So we had 100. Let's start with 1500 meters. Now notice we're not talking about meters, we're talking about millimeters. So first we have to think about what we mean by millimeters. There are 1,000 millimeters is 1 meter. Okay, so milli means 1,000th. So 1,000th of a meter, 1,000 thousandths of a meter will equal 1 meter. Okay, so in order to get from meters to millimeters, we would multiply by 1 meter would be on the bottom of this conversion, and 1,000 millimeters would be on the top, because remember, we always want to make our units cancel. So now meters is on the top, meters is on the bottom, and they cancel. And now when we multiply 1,500 by 1,000, we are in millimeters. So let's write that. 1500. When we multiply by 1,000, that's just going to be adding 3 more zeros. And that is now in millimeters. Okay, so 1, 2, 3, comma, 1, 2, 3, comma. All right, so if we were going to write it in standard form, isn't that the standard form? Standard form is our normal form. Okay, so now we're going to write 1.5 times 10 to the 6th millimeters. That would be the scientific notation. So this would be the A answer. This would be the B answer to the A and the B. And then we're going to check. So remember, in 1,500,000 millimeters, the decimal is at the end. But to get it in scientific notation, we need the decimal to be after the first non-zero digit. Okay, and so we're going to move it 1, 2, 3, 4, 5, 6 times to the left to get that decimal in the right spot. So 1.5, but since we moved it 6 times to the left, we really divided by 10 to the 6th. So in order to compensate for that, we must multiply by 10 to the 6th to get it in its proper scientific notation. So that is example 2. And here they're showing you example 2 just the way that we did it. So now let's look at this. Scientific calculators will display the results of an operation in scientific notation if the number would otherwise exceed the display capabilities of the calculator. For example, to multiply 1 million by 1 million, we would enter 1 million times 1 million equals, okay, but that number is bigger than the display on the calculator will display. So let's think about this. Could we multiply? So we know that when we multiply those out, we're going to get 1. Okay, so every time we multiply by 10, we add 1 0. So we're going to add a 0 for each one of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's write it in standard form. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now that decimal is bigger, is right at the end, and that number is bigger than most calculator displays. Usually a calculator display is 8 little slots for you to put the numbers in. Sometimes 10, but really they don't go much bigger. Okay, so let's go backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we would say that is 1 times 10 to the 12th. Okay, and that will fit in your calculator display. Okay, so let's go to the next slide here. Okay, so the answer 1 trillion contains more digits than can be displayed by most calculators. Instead of displaying 1 trillion in standard form, the calculator displays 1 trillion in some modified form of scientific notation. So, as we said, it was 1 times 10 to the 12th, or it might be 1, and then this little 12 up here indicates times 10 to the 12th. Okay, so the form of the scientific notation is A times 10 to some power. Okay, we'll just put it R. And when you have a calculator that displays in this form, this right here in the front would be the A, the number in the front of the scientific notation, and this 12 would be the exponent on the 10. It's a shortcut notation. Okay, so it says on a calculator, multiply the speed of light, which is 300 million meters per second, times the approximate number of seconds in a year, 31,500,000, to find a light year in meters. Okay, now it says use your calculator to multiply the measure of light year in meters by 10. Use the law of exponents to explain the result. Now, are you likely to have this kind of space on your calculator to do all of this? No, not likely. You'll be able to enter the original numbers, but you won't be able to get the answer. So we're going to look and see if they give us what the answer is, and if not, we're going to do it ourselves. So, nope, they don't give us the answer, so let's look at it. So let's first multiply this one, write it in scientific notation. So we're going to, oops, let me get back here in the right mode. We're going to write, oh, we'll change colors. 3, and let's see how many, 1, 2, 3, 4, 5, 6, 7, 8. So 3 times 10 to the 8th. And we're going to multiply times, this is a real cool thing about scientific notation. Now we're going to put our decimal right here because it's right after the first non-zero digit. So it's going to be 1, 2, 3, 4, 5, 6, 7, 10 to the 7. Because we're having to move it 7 to the left, we have to compensate by moving it back. And then this is going to be 3.15. 3.15. See, we don't want to lose any of our accuracy when we change to scientific notation. We don't want to change our number at all. We just want to make things a little easier. Now, the cool thing about it is I can multiply this pretty easily because when I'm multiplying scientific notation, I take the two A parts and I put them together and multiply them. So we know that 3 times 5 is 15, and then I carry the 1. 3 times 1 is 3, plus 1 is 4, and I'm going to have a decimal, and 3 times 3 is 9. So 9.43 is these two numbers multiplied together times, and then I'm going to multiply these two together. And when I multiply like bases, we've learned I add their exponents. So 8 plus 7 is 15. I'm going to get 10 to the 15. That is not going to fit on your calculator. Okay, but that is the answer. Okay, that is the answer. So, scientific notation makes multiplication much easier of large numbers or very, very small numbers. So let's look at the practice. Write 2.5 times 10 to the 6th with digits. So first let's write it out in scientific notation. 2.5 times 10 to the 6th. And now we're going to write it with digits, which means we're going to write it in its standard form, which means I'm going to take this decimal and move it 6 places to the right. So 2, we're going to do it like this. I'm going to put it down here, and then I'm going to put 1, 2, 3, 4, 5, 6. I'm going to fill in with zeros. Now, I'm going to take away this decimal. But guess what? Since this is 1, 2, 3, comma, 1, 2, 3, comma, I can now just see if I can do this. Ha! Look at that. Okay, so it's 2,500,000 is the answer. All right, B. Use words to write 1.8 times 10 to the 8th. Use words. All right, so words to write. Okay, so 1.8 times 10 to the 8th. I guess maybe they want me to put it in standard form first. Let's try to do that. 1.8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. We're going to try this and see if this is what they want. Okay, so let's see what it is. 1, 2, 3, comma. 1, 2, 3, comma. All right, so we would write this as 180, 100. This thing is very hard to write out. Very difficult. Okay, so I'm going to just say it because it's very hard. 100. Now I think I can do it because 180. 180 million. Okay, so that is this in standard form and in words. Write each number in standard form. So the first number is 2.0 times 10 to the 5th. So we're going to go 1, 2, 3, 4, 5, 0, 0, 0, 0. Now the decimal goes on the end, and 1, 2, 3, comma, 1, 2, 3. So 200,000. 200,000 is the answer. Okay. I'm not sure why this is A. Okay, let me see what this goes to. E. It just sort of popped in there. Well, let's go ahead and do it. I don't know why it's out of order and why it's A. I bet that was supposed to be up there with our speed drills at the beginning. Okay, yes, it was. And I think I just forgot to take it out. Let's look real quickly. And A. Yes, we already did that one. So this one is going to end up being just out of there. Okay, so now we're doing C, but I forgot D. D didn't show up in here. Oh, well, we're just going to go with what we had. I think I lost something in my PowerPoint. No biggie. So this one we're going to multiply by 10 to the 3rd. Now, isn't that just going to move this to the right 3 places? So 1, 1, 2, 3, decimal on the end. So 1609 is the answer. Okay, times 10 to the fourth. 1, 2, 3, 4. So let's fill these in with zeros. So now 1, 2, 3, comma, 30,500. These are really kind of fun. I think they're kind of fun. All right, so here we are on G. It says write each number in scientific notation, and we have the decimal here at the end, so we're going to move it 1, 2, 3, 4, 5 places to the left to get the decimal where we want it. Right behind the first non-zero digit is where we always want it to be. So we want it to be 3.65 times, and how many places did we move it? 1, 2, 3, 4, 5. So it's going to be 10 to the 5th power is in scientific notation. H. Okay, so our decimal place is here, and we need to move the decimal place to here. So how many steps is that? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be times 10 to the 8th. We moved it 10 to the left to get it in the right spot. That's dividing by 10 to the 8th. So we're going to have to multiply it by 10 to the 8th. So on the front, we put 2.95 till we get to the end of all of the non-zero digits. We want to make sure we are as accurate as we were in the standard form, but we now have it in scientific notation, which is much easier to work with. So now we're doing 70,500, and the decimal is here. But we want the decimal to be here in our scientific notation. That is a motion of 4 steps to the left, so it's going to be 10 to the 4th, moving it from there back to the right to get it back where we want it to be. So 7.05. Notice that I always go to the end of the non-zero digits. And that 0 in the middle is holding a spot, so I have to have it there. Okay, 25 million. First, I'm going to write 25 million. 25, comma, 1, 2, 3, comma, 1, 2, 3. So that's 25 million in standard form. So I'm going to, my decimal's right here right now, and I want it to go right here, right after the 2. So it's going to be 2.5, and then I need to see how many spots did I move it. 1, 2, 3, 4, 5, 6, 7 places. So times 10 to the 7th. Okay, and this is your problem set now. Okay, so not all of these will have to do with scientific notation. This is your actual homework. The lowest point on dry land is the shore of the Dead Sea, which is about 1,292 feet below sea level. Less than 20 miles from the Dead Sea is the Mount of Olives, which is 2,680 feet above sea level. What is the elevation difference between the shore of the Dead Sea and Mount of Olives? Okay, so we know that the shore of the Dead Sea is below sea level. So we're going to give it a negative 1,292. It has a negative elevation, doesn't it? And then we have the Mount of Olives, which is 2,680 above. So we're going to give that a positive 2,680. Now, positive is understood, but I'm just going to give it a plus, just so we know. That's positive, that's negative. And so we're trying to find the difference between them. So I'm going to subtract them. 2,680 minus a negative 1,292. 9, 2. Okay, now we remember that when we minus a minus number, it ends up being the opposite of a negative is the positive. Okay, so what we're really doing is this number plus this number. Okay, so let me see if I can move my little box up and have some room. So we're going to do 2, 6, 8, 0 plus, because the minus a minus, we're going to do 1, 2, 9, 2. And now we are adding the two together. So we have 2 and 17. So we'll carry. And 8 plus 1 is 9, and 2 plus 1 is 3. So we have 3,972 is the elevation difference between the shore of the Dead Sea and the Mount of Olives. Number 2 says about 7/10 of Greece's mainland is mountainous. About what percent of Greece's mainland is not mountainous? Okay, well, we're going to think of the whole of being Greece's mainland. So if 7/10 is mountainous, then how much of Greece will be left as not mountainous? Okay, and we know that the whole is 1, or 10/10 is a whole. So all of Greece would be 10/10, and 7/10 is mountainous. So wouldn't it be 10/10 minus 7/10, or 3/10? That would be non-mountainous. Hopefully that makes some sense. The Great Wall of China is about 1,500 miles long. If there are about 8 towers distributed along each mile, about how many towers are on the Great Wall of China? So we've got each mile is going to have 8 towers. So if it's 1,500 miles long, and each and every one of those miles has 8 towers. Now we could write this out more formally. We could say 1,500 miles times 8 towers per 1 mile. Okay. And then we have miles cancels miles, and it shows us that we're just going to multiply 1,500 by 8, and we're going to multiply to get the answer. So 0 times 8 is 0, 0 times 8 is 0, 5 times 8 is 40, carry the 4, 1 times 8 plus 4 is 12. So approximately 12,000 towers on the Great Wall of China. Classify this triangle by angles and sides and find its area. Okay, now remember, when we're classifying by angles, we're talking about, is it acute? Is it right? If we're classifying by sides, we're talking about isosceles, equilateral. So since this one is 3, so they're showing you 3, they're showing you 4. Okay, now this one over here is, if it were a right triangle, this one would be bigger than either one of the sides. It is obtuse, which means that this one is even bigger. Okay, so because the angle is increasing, the side is increasing by proportion. Okay, so this one is scaling because that third side is going to be bigger than either one of the 2 sides that it had. So it's going to be bigger than 3, and it's going to be bigger than 4. So we're going to say this is a scaling That is classifying it by its sides. Okay, and since this angle here is bigger than 90, this is an obtuse triangle. Okay, so we classified it by side and angle, obtuse. And now we're going to find the area. Well, area of a triangle is 1/2 base times height. And the base is 3. And the height is 4. The height is always straight drop down. And then we're going to take 1/2 of that. So we have 1/2 times 3 times 4. 3 times 4 is 12. Divided by 2 is 6. Since this is area, I'm going to say 6 square meters, because that M stands for meters. Okay. And number 5. If the largest angle of a triangle in problem 4 is 104, then the sum of the measures of the two acute angles is how many degrees? Notice they said the sum of the measures of the other two angles. So they're going to go back here. This one is 104 because they just told us it was 104. And then they're saying, what are the other two angles going to add up to be? Now, these are all different sizes, so I should put a different kind of hack mark in each one. Okay, so 1 plus 2, these two triangles. And we know there's 180 degrees in a triangle. So we can figure that out by saying 180 minus the 104 will be the sum of these two angles together. So 180 minus 104 is going to be 76. So the sum of the other two is, so we'll say sum equals 76 degrees. Number 6, on Earth, a kilogram mass weighs about 2.2 pounds. A 16-pound bowling ball has a mass of about how many kilograms? Okay, express your answer to the nearest whole kilogram. So it says the kilogram mass weighs, so 1 kilogram on Earth is 2.2 pounds. Okay, a 16-pound bowling ball has a mass of how many kilograms? Okay, so we're going to take the 16 pounds and we're going to multiply it by a conversion factor, which is either going to be, and I want you to tell me which one you would use. Would you say times 1 kilogram divided by 2.2 pounds? Or would you say 2.2 pounds over 1 kilogram? I'm sorry, this is really sloppy. This is very hard to do writing like this on the computer. But notice, don't I want, so here pounds is in the numerator. Don't I want to cancel out pounds and get to kilograms? So which one of these would I use to cancel out the pounds? Don't I need a pounds in the denominator, which would mean I need this one? Okay, so we're going to put 1 kilogram on the top. We're going to put 2.2 on the bottom. We're going to multiply. The pounds are going to cancel the pounds. And we're going to say 16 divided by 2.2. Okay, so let me see if I've got a spot to do that on. Oh, I don't even have a spot. So let's see if I can insert a little slide. So we have 16 divided by 2.2. And we're going to slide this over 1, add a 0. put our decimal point there, there. 22 into 16. I'm going to say maybe, well, let's try 6. 6 times 2 is 12. 12, 13. I think it's going to go one more time. Okay, so let's do 7. 7 times. 7 times 2 is 14. We're trying again. 7 times 2 is 14. 15. Yep, 150. So all we have to do is say 160 minus 154 is 6. Okay, so I have to go and get a marker. Okay, so 160 minus 154 is 6. So we're going to have it go 7 whole times with 6 out of 22 left over. Now it said round to the nearest kilogram, and this is not going to round up, is it? 6 is less than 11, which would be half. And so we would just leave it at 7. So 7 kilograms is going to be about the same as 16 pounds. And we are moving to our last problem. And it says simplify using rules of exponents. Now we know when we multiply like bases, we add the 2 exponents. So we can put a little plus sign. 3 plus 4 is 7. So m to the 3rd times m to the 4th is m to the 7th power. And then when we divide, we subtract the exponents. So this is 6 minus 2 is 4. M to the 4th, and we have thoroughly covered lesson 28, all about scientific notation, and I hope you will find this video helpful. This is Mrs. A, and may God bless your day.